Good evening, cosmic voyagers. Tonight we embark on an extraordinary journey, not just across the vast tapestry of stars and nebulae, but inward, towards a celestial body that has captivated humanity since time immemorial. Imagine, for a moment, soaring through the inky blackness, past swirling galaxies and distant suns, until a familiar, radiant orb grows larger in our view. It is our closest celestial neighbor, the Earth's silent companion, the Moon. For millennia, our understanding of the Moon was limited to what we could see with our own eyes, and, later, through early telescopes. But the true scientific unveiling of our neighbor accelerated dramatically in the 20th century. The Cold War rivalry between the United States and the Soviet Union ignited the space race, a period of intense technological competition that would propel humanity to its greatest adventure. The Soviets achieved several incredible firsts, including the first probe to impact the Moon, and in 1959, the Luna 3 mission captured the very first images of the Moon's mysterious far side. But the ultimate prize was to land a human on its surface. This goal was realized by the United States Apollo program. On July 20, 1969, Neil Armstrong and Buzz Aldrin of Apollo 11 took those first historic steps, a moment watched by hundreds of millions back on Earth. The Apollo missions were a scientific goldmine, bringing back 382 kilograms, 842 pounds, of lunar rocks and soil. Analysis of these samples confirmed the giant impact hypothesis, the theory that the Moon formed from the debris of a massive collision between a Mars-sized object and a young Earth. These rocks provided a pristine record of the early solar system's violent history and revealed that the Moon's dark plains, or Maria, were formed by ancient volcanic eruptions. But our learning didn't stop when the last Apollo astronaut returned home. In the decades since, and especially in recent years, a new wave of robotic explorers has completely revolutionized our understanding. Perhaps the single most important discovery of this new era is the confirmation of water ice. Missions like India's Chandrayaan-1 and NASA's Lunar Reconnaissance Orbiter, or LRO, used sophisticated instruments to detect significant deposits of water ice hidden in the permanent shadows of craters at the Moon's poles. This wasn't just a trace amount. We're talking about potentially billions of tons. This discovery transformed the Moon from a bone-dry world into a potential resource depot for future human exploration, a place where we could source drinking water, breathable air, and even rocket fuel. More recently, China's ambitious Chang'e program has opened new chapters in lunar exploration. In 2019, the Chang'e 4 mission achieved the historic first-ever soft landing on the far side of the Moon. Its Yutu-2 rover continues to explore this unknown territory, giving us our first ground truth data about the geology of the side of the Moon we can never see from Earth. Then, in 2020, the Chang'e 5 mission successfully collected and returned the first new lunar samples in over 40 years. These rocks were from a much younger volcanic region than anything Apollo brought back. Their analysis revealed that the Moon was volcanically active far more recently than we ever thought, forcing scientists to rethink the timeline of the Moon's thermal evolution. Astonishingly, studies of these new samples also found direct evidence of water in the form of glass beads within the lunar soil, suggesting an internal water source on the Moon. Modern orbiters have also given us an unprecedented view of our neighbor. NASA's LRO has created stunningly detailed, high-resolution 3D maps of the entire lunar surface, revealing everything from the location of the Apollo landing sites to potential resources. We have discovered vast underground lava tubes, tunnels carved by ancient magma flows that are large enough to house entire cities, offering natural protection from radiation and micrometeorites for future lunar bases. We now know the Moon has a tiny, partially molten core, experiences moonquakes from tidal stresses and thermal changes, and is surrounded by a tenuous but detectable atmosphere called an exosphere. Our silent gray companion has been revealed to be a dynamic and complex world, one that still holds countless secrets. As we plan our return with programs like Artemis, we go not just to walk in the footsteps of giants, but to build on a new foundation of knowledge, ready to unlock the next set of mysteries the moon has waiting for us.